Welcome to G Fun Facts Online, where we dig deep into the science that shapes our world. What if I told you that long before humans invented calendars or thermometers, the Earth was keeping a diary? A detailed record of every heat wave, every ice age, every flood and drought. The incredible thing is, this diary isn't written in a book. It's etched into stone, buried under the ocean, and recorded deep within the planet's crust. Today, we're going on a journey to the past, venturing into subterranean archives to read these ancient scripts. This is the world of paleoclimatology. First stop, caves. You might think of caves as static, silent places, but they are incredibly dynamic environments, meticulously recording the climate of the world above. Those beautiful formations, the stalactites hanging from the ceiling and the stalagmites rising from the floor, are known as speleothems. Think of them as timekeepers in the dark. They form drip by drip as rainwater seeps through the ground, dissolving minerals. As this water trickles into the cave, it leaves behind tiny mineral deposits, which build up in layers over thousands of years. Each layer is a snapshot of the past. A thick layer might mean a very rainy period. A thin one could indicate a drought, but the real secrets are locked in their chemistry. By analyzing the oxygen and carbon isotopes in these layers, scientists can reconstruct past temperatures, rainfall, and even the types of plants that grew overhead. And with new dating methods, like UPB dating, we can now read these climate records going back much further than the previous half-a-million-year limit. These cave formations tell amazing stories. For instance, speleothems in China have helped us reconstruct the history of the Asian monsoon over the last 640,000 years. Next, we travel from caves to the bottom of the ocean. The seafloor is another vast library. Over millennia, a constant shower of particles, dust, minerals, and the microscopic shells of marine life settles on the seabed, forming thick layers of sediment. Scientists use special drills to pull up long cylinders of this mud, called sediment cores. These cores are like deep-sea scrolls, providing a vertical timeline of Earth's history. The tiny fossilized shells within these layers, from creatures called foraminifera, are a goldmine of information. The chemical makeup of their shells directly reflects the temperature of the water they lived in. By analyzing these microfossils, we can map out past sea surface temperatures and changes in ocean currents. And the stories these cores tell can be dramatic. They've been used to reconstruct the history of tsunamis off the coast of Japan. On an even grander scale, cores from the Gulf of Aden have shown how periods of warm, wet weather in Northeast Africa may have created green corridors that allowed early humans to migrate out of the continent. Our final method is perhaps the most unconventional. We're going to use the Earth itself as a giant thermometer. This technique is called borehole thermometry. It works on a simple principle. The ground has a memory of past temperatures. Heat is always flowing from the Earth's core outwards, but changes in the surface temperature, like a long cold spell or a warming trend, create subtle ripples in this heat flow that travel slowly down into the rock. By drilling a deep borehole and measuring the temperature at different depths, scientists can work backwards and reconstruct average surface temperatures over centuries. It's a fantastic independent way to verify what other records tell us, and it has clearly shown the cooler temperatures of the Little Ice Age and the warming that followed. So why does all this matter? Reconstructing ancient climates isn't just a cool academic puzzle. It gives us the context we need to understand the speed and scale of the climate change we're experiencing today. But even more than that, it's rewriting the story of humanity. We're learning how climate shaped the very course of human evolution, opening pathways for our ancestors to spread across the globe and influencing the rise and fall of entire civilizations, like the Indus Valley. And in a mind-blowing merger of fields, scientists are now able to extract ancient human DNA directly from cave sediments. This means we can find traces of our ancestors even without any bones, identifying entire extinct human lineages from a 25,000-year-old sample of soil. The Earth has a long and dynamic history, recorded in these hidden archives all around us. By learning to listen to these whispers from below, we gain a much deeper understanding of our planet and our own place within its incredible story. Thanks for tuning in to G Fun Facts Online.